Okay, this lesson is on slope fields, and it literally is just a field of all the different slopes. And we know that the derivative is the slope at any given point. So what you're going to do is you're going to make a bunch of different dashes, and they are going to represent the slope of the function at any given point. And the dash is going to kind of be in the direction and the steepness of the slope that you find at that point. Okay. So it says given dy dx equals x. So that is my derivative. So this is the slope at any given point, because that's what the derivative is. It is the slope at any given point. So what I'm going to do is I'm going to come in here and find slopes using these x's and y's. So I'm just going to pick a point. Like let's pick 0, 0. Well, if my point is 0, 0, and this represents the slope at that point, and the slope is x, it's the x value of that point. So the slope would be 0. If I pick the point 1, 1, again, my slope is x. It's the x value, so it's a 1. If I pick the point 1, 2, again, the slope for this problem is just x, so that would be a 1. So you kind of get the idea here that no matter what your x, as long as your x is 1, it doesn't matter what your y is, your slope is going to be a 1. Okay, so let's stop right there and let's come in here and do some of these dashes. So at 0, 0, my slope is 0. Well, slope of 0 is a horizontal line, so I'm going to come in here at 0, 0 and do just a really small dash that is a horizontal line. So that represents the slope at that particular point. And then if my point is 1, 1, so that's this point right here, and we found the slope to be 1, so that's rising, and that's the perfect diagonal. So I'm just going to do a little dash right there that is really close to trying to be the perfect diagonal. And then at the point 1, 2, which is this point right here, my slope is also a 1. And then we said no matter what my y's are, if my x's are 1s, then my slopes are going to be 1s. So at all my x's that are a 1, my slopes are going to be 1. I can do the same thing. Let's try the point 2, 1. Well, since my slope is x, my slope is going to be 2. So at 2, 1, which is right here, my slope is 2, which is positive but steeper. And again, I can do the same thing I did with the 1s at 2, I don't know, 8. The slope is still going to be a 2. So at any x value of 2, my slope is going to be a 2. Oh, see, that's not steep enough. Oops. And here too. Let's try some negative numbers. Let's go -1. I don't know, 1. Well, my slope's going to be a -1 because, again, my slope is the x value. So at all my -1s, we picked -1, 1, my slope is going to be a -1. So now my line is going downhill, but it's the perfect diagonal for all the x's that are a -1. And again, I can do the same thing for 2. 2, whatever, my slope is going to be, or -2, whatever, my slope is going to be a -2. So that's still downhill, but that's steeper. That may have gotten a little too steep. Okay, let's do these. Let's say x is 0. Again, who cares what your y is? Because the slope of this line is always x, so my slope will always be 0. So at all these x's, where my x value is 0, my slope is going to be a 0. Okay, so notice, and this is really important, if your slope formula, which is what the derivative is, has no y's in it, then vertically all your slopes are going to be the same. Because it's saying I don't care what y is, it's just based on the x value. So whatever x is, that's what my slope is. It's completely irrelevant about y. Now, they're not all like that, but when you do see that, when you do see a slope formula that has no y's in it, then vertically all these little tick marks are going to be the same. Okay, now you're done. This is the slope field. If I went to 3, it would just be even steeper. If I went to 4, it would just be even steeper. And then if I went to -3, it would just be steeper, just downhill now. Okay, can you start to kind of see if you were to put a function in here and these were all its slopes, that it would do, I don't know, let's say it goes through this point, then it would do something like that. If it happened to go through this point, then it would do something like that. Well, that's a parabola. Okay, let's see if this makes sense. Think about this. If dy dx equals x, multiply both sides by dx. Now take the antiderivative. Oops, sorry. Which is a parabola that opens up, that's a little skinnier than normal. Okay, so all those little blue tick marks, that's the actual slope field. Most of these are matching, where you have to match the graph or match the function with its slope field. Okay, number 2. Same thing, except now the equation for my slope is y. So I could care less what x's are. If y is 0, my slope's going to be 0. If y's are 1, my slope's going to be 1. If y's a -1, slope's going to be -1. Okay, so y's. If y is 0, my slope is going to be 0. If y is 0, my slope is going to be 0. I don't care what x is. If y is 1, my slope is going to be 1. All my y's that are 1s, my slopes are going to be 1s. If y is a -1, my slopes are going to be a -1. Two, going to get a little steeper because my slope's going to be a 2. -2, a little steeper, just negative. Okay, so again, the equation of my slope has just y's, which means I don't care about the x's, which means they are the same horizontally. So look for that pattern. Again, it doesn't always happen, but when that does happen, it helps you eliminate a lot of choices really quickly. And then if we were going to do the same thing, let's see, if I have dy dx equals y, and I get my y's together, I would divide by y and multiply by dx, and that's going to be ln of y equals x, and then if you snail it, that's e to the x, and the graph of e to the x looks just like that. Now, it doesn't have any values down here. The slope field shows the slope for any points, but this equation only lives right here. Now, I could shift it based on whatever my C was. So don't think that your graph has to, I don't know, somehow fit all the tick marks, because it doesn't. Okay, now this one has an X and a Y. Okay, so let's start easy. If I go 1, 1, then my slope's going to be 1. I'm doing what the equation says. I'm multiplying. If I go 1, 2, it's going to be a 2. If I go negative 1, 1, it's going to be a negative 1. If I go negative 1, negative 1, that's going to be a positive 1. Let's throw some zeros in here. 0, 0 would be a 0. 0, 1 would be a 0. In fact, anything with a 0 in it is going to be a 0. Okay, so let's focus here. Anything with a 0 in it, if I multiply it, it's going to be a 0. So for all my y's that equal 0 and all my x's that equal 0, my slopes will be 0. Okay, the point 1, 1, my slope was 1. The point 1, 2, my slope was 2. 1, 3 would be 3. 2, 1, multiply those together, that would give you a 2. 3, 1 would be 3. I have a hard time drawing these. Steepness. Okay, let's go negative. Let's go negative 1, 1. If I multiply those, that gives me a negative 1. Negative 1, 2 would give me a negative 2. That would give me a negative 3. If I go back here, negative 2, positive 1. If I multiply those, that gives me a negative 2, which should look steeper than that. And this would give me a negative 3. If I went here and did negative 2, 2, that'd be a negative 4. It's crazy steep. If I went right here, that'd be 2, 2. That'd be a positive 4. Oop, that's a little too steep. Let's go south of the border. Let's go 1, negative 1. Multiply that, give me a negative 1. 2, negative 1 would give me a negative 2. And that would give me a negative 3. All right, now when I'm over here and everybody's negative, a negative, negative 1, when I multiply those, would give me a positive 1. Negative 2, 1 would give me, no, negative 2, negative 1 would give me a positive 2. And negative 3, negative 1 would give me a positive 3. This one would give me a negative 1, negative 2, so positive 2, so steeper. Negative 2, negative 2, negative, or positive 4, so really steep. Negative 3, 2 would give me a positive 6, crazy steep. Let's go over here. 1, negative 2 would give me a negative 2, negative 2, or positive 2, negative 2 would give me a negative 4. Should be steeper than that. And positive 3, negative 2 would give me a negative 6, which is crazy steep. Okay, so I think we've kind of, we're good. That's all it wants. That's absolutely all it wants, is just a field of slopes. Okay. Let's try this one. Let's go 0, 0. I don't know, 0, 1, 0, 3, 1, 1, 2, 1, negative 1, negative 2. I'm just making points up. Negative 1, negative 1. What have I not done? A negative and a positive, and a positive and a negative. Let's try that. Okay, now we're doing y minus x. 0, y minus x, y minus x, y minus x. In fact, anywhere where they are the same, it's going to be a 0. Okay, pause on that. Anywhere where x and y are the same, it's going to be a 0. So that's going to give me this. There you go. Okay, anywhere where y is bigger, my slope's going to be positive, and anywhere where x is bigger, my slope's going to be negative. All right, so 2, 1, that's going to give me a negative 1. Negative 2 minus a minus 1 is going to give me a negative 1. Negative 1 minus a minus 1 is going to give me a 0. 1 minus a minus 1 is going to give me a 2. Minus a minus, that's going to give me a negative 2. Okay, so let's try 0, 1. So 0, 1 would be here, and that slope is a 1. Then 0, 3, and that slope was a 3, so really steep. 0, 2 would be a 2. Let's see, 1, 1 was a 0. We have that one. 2, 1, that's here, would be a negative 1. Negative 1, negative 2 is a negative 1. Negative 1 is a 0. Negative 1, positive 1 is a 2. And 1, negative 1 here is a negative 2. Let's see, let's fill some more in. Let's go here. So that is negative 2, negative 1, and y minus x would be 1. Let's go here. That's 2, negative 1, so negative 1 minus 2 would be a negative 3. Really steep. Let's go here. So let's see, that's negative 2, 1. That's positive 3. Okay. I think we're good. I mean, you could sit here and fill more in, but I think that would be enough to get you to be able to pick out the picture. Okay. Given y prime, which is the same thing as dy dx, equals 1 over x, sketch the slope field. 1 over x, which is your m. Okay. 1 over x, the first thing I think of is when x is 0, this sucker's going to be undefined. Undefined is a vertical line. So at all my x's equal 0, I'm going to have vertical lines. I also know that this in absolutely no way, shape, or form has anything to do with y, so my y's don't matter, which means that I'm going to have vertical alignment. They're all going to be the same all the way up. And again, this just makes life easier if you can see these patterns. If x is a 1, 1 over 1 is 1. So for all x's that are a 1, my slope is going to be a 1. Again, because it doesn't matter about the y's. There are no y's in my formula. For negative 1, my slope is going to be a negative 1. If I'm a 2, then my slope is going to be a 1/2. So if my x is a 2, my slope is a 1/2, which is flatter. Oh, probably not. Flat. And then if I'm a negative 2, then my slope's going to be a negative 1/2. So negative and flatter. Okay, now let's look at this guy. This is dy dx. If I multiply both sides by dx, and then if I take the integral, that's the ln of x plus c, and the graph of ln of x. Remember, it's the inverse of e to the x. And he's the guy that does this. Goes through the point 0, 1, has an asymptote here. So you can kind of see that it makes sense that he goes with the flow in the slope field. Okay, so that's how you create a slope field, which very rarely you're going to be asked to do, but you need to understand that so that you can do these. Okay, so this is matching. It says match each slope field with a proper differential equation below. Follow the general solution for each, find the general solution for each differential equation. The particular solution that goes through 0, 0 has been sketched. So the lines that you see, the graphs, these things, this is not a guarantee. Like it could do this. They're just saying, hey, we've graphed the one that goes to the point 0, 0 just to help you out. They didn't have to do that. And although they probably won't in the future. So if I know that that's the derivative, instead of doing the chart, can you just take the antiderivative of that, and that would give you sine of x plus c. Don't forget your plus c, because this is not a definite integral when you do this. And sine of c, if that's the original function, then you know it's going to look like this. So 6 is c. Again, these are the graphs of the original function. The equations that I'm giving you are the derivatives, so they are the equations of each individual slope. Number 7, I would give you x squared plus c, and you know that's a parabola. Got to be a. You take the antiderivative of this, cubic, got to be b. And then this guy, don't get freaked out by the pi. That does not mean that this is trig. Pi over 2 is a constant. So this is linear. This is mx plus b. It just has an odd slope. And you remember pi is a number, 3.14. Negative over 2 just gives you a slope. So he's d. So I hope you see how easy these can be once you figure out what they represent and what they mean. Another kind of tool that I want to give you is, let's look at this one. Okay, so it says, which of the following slope fields represent dy dx equals x squared minus y squared? Okay, so the first thing to do, so it's multiple choice. So the first thing to do is to find a convenient point and find the slope. Look for things that are zeros. Okay, so at 0, 0, I know that my slope should be 0. So I'm going to look at this. Well, he's a 0, he's a 0, he's a 0, he's not. So he's out. Okay, so now let's try another convenient point. So they tried 1, 1. So they plugged it into my slope formula, which is the derivative, and I got 0. So at 1, 1, I should be 0. Well, he's not, so he's out. He's not, so he's out. He is, so he wins. Again, this is not difficult, but you just have to have experience with them so that you can handle them. But these need to be problems that you get right all the time. So take your time, especially on your homework. The answers to the homework have lots of detailed explanation in them. So please take your time when you go through the homework and look at that detailed explanation. And honestly, I would be totally fine. Just pull up the answers and just walk through the problems and read through my work and the explanation and make sure that you understand it. If you want to do the homework on your own first and then go and check it, that's fine too. But I really don't think these are that difficult, but you need to make sure that you expose your brain to trying to figure them out so that you don't miss these. Because like I said, these are ones you need to get right. So take your time, go through the homework, absolutely look at the answers that are posted, but pay close attention to the explanations that are written off to the side on some of them.